Okay, back at it again. Invert binary tree. Classic, but doing it in Swift this time. Given the root of a binary tree, invert the tree and return its root. So here you see here in the example, the root's the same, but like it's almost like the subtrees. We put this subtree on the right side and then put the right subtree onto the left side. All right. And then another example here. 2, 1, 3, switch 3 and 1. And if it's empty, we can have empty. Okay. We do nothing. So, and then we want to return a tree node, potentially. And a tree node definition, there's going to be a value, a left and right, and then a bunch of initializers, but I think all, yeah, so these are default values, then this is one with the value given, and this is one with the value and the left and right given. I feel like why didn't they just do like 0, like, sorry, 0 there, 0 over here? Like, why didn't they just put default values over there? I wonder. Maybe that's just another way to do it. So some questions to ask. Can this root be nil? Is this is just a binary tree. It's not like a sorted binary tree or anything. I don't think the values actually will. Yeah, I don't think the value, like, I don't think, I forget the term. Is it maybe a balanced binary tree? Or complete? I don't think it's complete. I think it's a balanced binary tree. Or maybe a binary search tree. Yeah. Yeah, I mean, honestly, that's really, like, that's really all the questions I have. So it does give the range of the values. I don't think that's important, though. It can be 0. So how do we go about doing this again? At a high level, we want to take whatever's on the left, put it onto the right, whatever's on the right, put it onto the left, at a very high level. No, hold on. I didn't look carefully. If you see here, if you just place the left subtree onto the right, the 1 would be here, the 3 would be here. And in this case, you can see it's reversed. So that's an important consideration to keep in mind. As a human, how would I do this? Like if I had this binary tree over here, how would I go about doing this? So I have 4, I have 2, I know this is going to take a bit of time, but 7, but I think this is, drawing a picture is really important. Okay. And 8. All right, and then we want to reverse the binary tree. So at each level, I'm noticing, at each level, the 1 goes all the way there, the 3 goes there, 6 there, 9 there. So rather than reverse it at like I was initially thinking like, okay, I'm gonna go all the way down to 1 and then do something. What that something will be, I have no idea. Yeah. So I don't think that's a good idea because I don't even know what I'll actually do when I get to 1. And then, you know, the thought that I mentioned about like just taking this subtree and putting over there, that won't work either. Because this 1 and 3 should be flipped. So what can we do? We do need to go through all the elements, I think. Or maybe not, I don't know. If I come to this level, right? Come to this level. I know we have a 2 and 7, okay? Then I would just reverse it, 7 and 2, and then append it to the appropriate place. I know this is left, and this is the right subtree, okay? Now here we have 1, 3, 5, 8. Now reverse is 8, 5, 3, 1. And then how do I know which ones go where? Right? I know this is a balanced binary tree, so at most there's 2 elements. And even if there isn't an element for one, that element will just be not null. I'm pretty sure. So we take the elements of each and then append it to the appropriate place. Left and right, left and right. And if we go a level more down, then there's going to be like 4 elements. So like 1 and 2 and 8 elements in total, right? So how do we reverse, like, so we reverse it, right? And then after reversing it, how do we know which ones go where? Yeah, a bit difficult to think about it because I don't know. As this is getting more complicated and there's more nodes being added at each stage, do I just like split this by 2 and then add it to the left and right? And same thing like here, like at this stage, it's being added to the left and right of one node, being added to the left and right of the second node. If we had a recursive solution, how would we do this? Like switching the mindset from an iterative solution of looking at each level one by one to like a recursive solution. At a high level, what do we want to do? And that's what I was trying to answer with this approach. So as a human, I know I can reverse this, right? And then when I reverse it, then I kind of start from the left side, right? The leftmost side. And then whatever is missing, right? So I see the left subtree, like, is missing. Hold on, what's the return type of this? A tree? Invert the tree and return its root. Can I create a new tree or? I guess that's another question. I'm assuming I gotta revert the nodes themselves rather than just the value inside, or does it not matter? Some more questions that are coming up in my head. But I do need to like sort out my thought process. As a human, I see 4 and then I see like change this to 7. Like, well, is that what I'm doing? I change this to 2. Okay, so I'm switching the left and right subtrees at this stage. Now at this stage, over here, can I just switch the left and right subtrees and call it a day? If I just do this, can I call it a day? The answer is no, because we know that we gotta consider this entire like level. Okay, we're 12 minutes in. I'm gonna watch a Leetcode video. It's embarrassing because I feel like I've done this question before. No, I've done this question before. I feel like I've done it multiple times now. So a bit disappointing that I'm relying on Leetcode and that I'm not able to solve it. But because time is precious, I'm gonna watch it, understand the concept, and then try implementing it. All right, I'll be right back.